Now we can take the example of some complexes and how to name them according to the rules. Okay, look at the first example. It's cobalt with the 6 amines. 6 means hexaamine, and here we have chloride. And you see, when the chloride is outside the coordination sphere, then it's no more a negative ligand, right? It is negative, but it's not acting directly attached to the metal ion, right? So we're not following the rules of O at the end of negative ligand, right? So we will name them like firstly with this name of a ligand, right? It's hexaamine cobalt. Yes, and next we need to mention the oxidation state of metal. You see, we have chlorine. Single chlorine is having -1 charge. We have 3 chlorine, so it's -3, right? So if we have -3, so it means we need to have +3 on coordination sphere, because resultantly we want to have 0 charge. You know, and amine is a neutral ligand, so it is having 0 charge. So resultantly these 3 positive charges all because of metal ion, right? So oxidation state of metal is 3, right? It's hexaamine cobalt 3, right? It's, if it is inside the coordination sphere, then we call it as a chloro, but if it is outside, so then we call it as a chloride. And there is no need to mention trichloride and all, right? If it's inside the coordination sphere, then we need to mention the number of ligands, you know, hexaamine. But if it is outside the coordination sphere, then there is no need to mention the number. Okay, now the next example, it is the complete name of complex. You know, you need to write hexaamine cobalt without space, you know, in a continuous form, and then chloride with the space. Okay, then we have what, you know, you see we have positive complex before the negative one in this complex, right? The cationic part. Here you can see the cationic part is, although before the anionic one, but let me confirm the structure. Is it without charge, molybdate? Yes. Okay, so we have 4 potassium, right? And potassium is a metal, and being a metal is electropositive because it's it's 4. So single potassium is having +1, so it's become +4. If it is +4, then charge on the coordination sphere would be minus, right? One more thing, if we have an overall negative charge on the coordination sphere according to the rule, then we need to add at the end of the name of metal. Oops. Okay, so name according to the sequence, right? So we have potassium, it's 8, so it's octa. It's cyanide, so it's cyano because it's a negative ligand. Potassium ke baad you need to have a space, right? So right way to potassium space octacyano without space, and the metal ion is it's molybdenum, so we need to write molybdate because it's -1. Molybdate, right? Molybdate. And because we are adding 8, because we have a negative charge, and the overall charge is it's -1 on the single cyano, and we have -8 if you want to have -8 charge on minus cyano. So resultantly we need to have how many charge on molybdate, right? We need to have +4 charge. You know, -8 + 4 is equals to -4, so it's like 4. Hopefully it's clear now. Okay, now we take another example, right? In this example we are considering this one. You know, we have overall positive charge. Firstly we need to find out the oxygen state of metal. Here we have chloro -1, amino is 0, and we have resultant +2 charge, and it's all because of metal, right? So cobalt is present in +2 state because here we have a charge, right, on the complex, right, which is already mentioned, so it is in the form of a ion, so you need to mention the ion, right, in the name of a complex, right? So I have selected a different kind of examples. So let's start with the chloro. You know, firstly the negative ligand, then the neutral ligand, penta amine continuously, right? chloropentamine, and we have the charge on the metal would be, yes, it's +3. It should be +3 because we have -1. We want to have +2 overall charge, so it's +3 -1 is equals to -2. So it's cobalt. I'm not adding cobaltate like in molybdate. Molybdate mein we are adding ate at the end of name of metal because of being negative coordination sphere. Here we have a positive one, which is quite normal. So it's cobalt, and the coordination number is 1 2 3, and it's in the form of an ion, so you need to mention ion. Right, so the complete name of this example is chloropentamine cobalt 3 ion. Okay, now the last one. Here you can see we have different type of ligands, right? So alphabetical order mein firstly you need to name the negative ligands according to the rules. So negative ones, it's cyano -1, chloro -1, nitro -1, right? And amine is 0, and we need to have -3 ho gaya, so we have +3 charge on the metal, right? So it's chloro, then we have cyano. I'm adding O at the end of both negative ligand. Chloro, cyano, right? Then we have nitro. It could be nitrito as well. Nitrito. But even if the nitro is also fine. Okay. Nitro. Uske baad we have neutral ligand, which is triamine. Right, and then the name of a metal, which is cobalt, without any space. The continuous, chloro, cyano, nitro, triamine, cobalt, without any space, right? And then the oxidation state of metal 1 2 3, right? So hopefully the things are more clear now, how to name different type of complexes, right? Then you can take we can do some other example if required. Okay, thank you.